Hi guys, this is Manoj here. I'm having around 15 years of industry experience. Okay, so let me walk you through a few of the concepts of DevOps. Okay, so guys, if I'll go back in the history and talk about the development process, so we used to develop everything in SDLC lifecycle process, and the delivery model we were using was the waterfall model. So this is our SDLC lifecycle is there, like requirement gathering, design, development, deployment, testing, maintenance. This is the SDLC lifecycle is there. When I talk about the SDLC lifecycle, like the delivery model, if I'm using the waterfall model, if I talk about the waterfall model, in waterfall model, we have suppose a project is there which I'm running in SDLC lifecycle. If I have 6 modules are there, and if I have 6 months of time is there, so I'll be running everything in sequential. Okay, so after requirement gathering, I'll be doing design, after doing our development, after doing deployment, but I'll be doing entire thing all together. Okay, so requirement gathering I'm doing all together. Okay, and design I'm doing all together, development I'm doing all together for all the 6 modules. Suppose guys, after 4 months in the testing cycle, if I'll get a major defect, it'll not be possible for me to fix it, because by the time I'll be losing the track. Okay, I'll be losing the track. So what is the biggest problem with the waterfall model is that I will not have a sequential feedback. Quicker feedback or sequential feedback I must not be getting with the waterfall model. This is the biggest problem is there of waterfall model. Second biggest problem is the optimal utilization. Suppose I have a project is there which will take 6 months of time, so I must be spending 1 month of requirement getting, 1 month of design, 1 month of development, 1 month of deployment. So in short, I must not be having kind of optimal utilization of the people, because 1 month suppose requirement gathering is taking for 6 modules, then other guys are sitting idle. Same way, if 1 month development is taking, other guys are sitting idle. So I might not be having a good utilization of the resources. So optimal utilization is not there. Okay, optimal utilization is not there of the resources with this model. So what people thought is, let's come in a model wherein we will give a quicker feedback and we will have optimal utilization of the resources. So people moved in incremental model lifecycle. Okay, for example, requirement gathering, design, development, deployment, testing, maintenance. Okay, so in agile methodologies, we are actually dividing everything into the chunks. Okay, dividing into the small chunks. Okay, and giving them okay a solution to give the quicker feedback. Now for each iteration, we are giving the quicker feedback that boss, this feature is working or not. Business will take a call whether this business will be working or not. For next feature, next iteration is there. For next feature, next iteration is there. If I'll compare with my example, for one module, one iteration is there. For second module, second iteration is there. For third module, third iteration is there. Okay, so with this model, we'll give a quicker feedback, and our red will turn into green with this model, But guys, does it solve my problem? No, it has actually created more challenges for me, because this model suggests me to go faster in the life cycle. Wherein I was going in live once in a 6 month, now I have to go live every 3 to 4 weeks of time. Okay, or maybe 2 weeks of time. This iteration we call it as a sprint, so we have to go live for each and every sprint or most of the sprint. So my challenges has increased. My code should be capable to go into the production in a short span of time. So when I'm talking about short span of time, it's a 3 to 4 weeks of time, which leads to major challenges for me. For example, now my deployment challenges has been increased. Earlier I was deploying once or twice. Now I'm deploying multiple times. My testing challenges has been increased. Earlier I was testing once or twice. Now testing has been increased. Okay, testing cycles has been increased. Environment maintenance has been increased. Okay, my code quality, we should ensure that code is going as per the expectation. Otherwise, once it reaches to the production, it gives us unforeseen defects which could have been avoided. Okay, now environment simulation, this is a big problem. Okay, and apart from that, people wants more control to infrastructure, more control to infrastructure, less dependencies on the teams. Okay, people wants more collaboratively, work collaboratively. Okay, so these are the challenges are there which people started facing. I would not say problems, I would say them challenges. So what is the solution to the problem is? Solution to the problem is only one, that is DevOps. Solution to the problem is DevOps. Okay, solution to the problem is DevOps. Sorry, it's not red, it's green actually. Yeah, solution to the problem is DevOps, and this is how DevOps concept has been started. Now in DevOps is an umbrella. Like as I told, few problems like deployment is one of the problem, or maybe testing is one of the problem, environment maintenance is one of the problem. Okay, so multiple problems are there in this guy. Okay, environment simulation, environment maintenance, control to the code quality. So entire thing apart from development will be falling under DevOps. So DevOps is a big umbrella. Okay, so when I talk about DevOps has multiple C's concept is there. So now DevOps should be clear to you guys why DevOps is required. When I talk about DevOps, there are 7 C's are there. So my here motive is not to connect with all the C's. Okay, but the important C we are discussing here is continuous integration. So like a lot of C's are there of DevOps. A lot of C's are there of DevOps. For example, continuous integration, continuous delivery, continuous deployment, like continuous integration, continuous delivery or deployment. Okay, and then continuous monitoring. Like that, guys, multiple C's are there of DevOps. C's I'm talking about, this is a 1 C, this is a 2nd C, this is a 3rd C. For example, continuous testing also. Continuous testing, continuous assessment, continuous feedback, continuous testing. Okay, continuous feedback and continuous assessment. So a lot of C's are there, guys, which people usually focus when they learn the DevOps. So our focus is here on continuous integration because we are learning Jenkins. So in Jenkins, we have a continuous integration is the tool is there. So let's understand the continuous integration. Okay, let's say this is a version control system is there. Could be Git, GitHub. Okay, And let's say a developer who's working here. Now suppose guys, his code has to go in a particular environment. You said dev or later QA or later SIT or pre-prod or prod. What kind of feedback I can give to a guy that your code is working fine as per expectation, okay, before it moves to the production? What kind of audits I can do for a developer, or what kind of feedback I can give to a developer for his code? Okay, so the first feedback what we can give is, boss, have you written your unit test cases and unit test cases are passed or not? This feedback I can give it to a developer first. Okay, second feedback is, I can tell him, boss, your code quality is up to the mark or not. Okay, so why code quality is required? Because guys, we have reduced the developer time window. Okay, initially he was getting 2 months time or 3 months time to develop the code. Now he's getting 2 weeks time, 3 weeks of time. So we have reduced his timings because we are in agile methodologies. So we should make sure that his code quality has been maintained. Second is code coverage. Second is code coverage. Okay, code coverage as in his entire code is being covered with unit test cases or not. Okay, the next is whether his builds are happening properly or not. Okay, and then afterwards testing is happening or not, deployment in any environment, per se dev QA, any environment, deployment is happening or not, and if required, small round of testing. But testing, I would say it's too early, functional testing to check, because by that time test cases might not be ready. Okay, so this is optional, guy. So guys, these kind of feedbacks are required before a guy moves his code to a respective environment. Okay, now guys, these multiple uh, features are there, or multiple feedbacks are there. Do you think we can run one by one, like first I will run this guy, second I will run this guy, third I will run this guy, fourth this guy, fifth this guy, or I should automate it, I should stitch them in a pipeline? Shall I stitch all these things to be a part of one pipeline, or we should run it one by one? We should stitch them in a pipeline, guys, right? Okay, let me stitch them in a pipeline. Let me stitch them in a pipeline. Okay, guys, so if I will stitch them in a pipeline, then shall I encourage developers to check in more frequently? If I will stitch them in a pipeline, is it not required for a developer to ask him to commit his code or integrate his code more frequently so that he'll get more frequent feedbacks? Shall we not encourage our developer to commit his code more frequently or integrate his code more frequently in the version control system so that he'll get more feedback, quicker feedbacks? Right, guys? So that is called continuous integration process. To overcome few problems which is being created by agile, you are asking developer to check in the code more frequently. That is called continuous integration process. Integrate more, integrate often, integrate very often. Okay, integrate fast, fail fast, pass fast. Everything is fast here, guys. Okay, that is called continuous integration process. So let's talk about the tools. So guys, this continuous integration has multiple tools are there in the market. Okay, which is the most famous tool in the market for which we are here to discuss? Jenkins, right? Jenkins is one of the tool. Apart from Jenkins, Bamboo, Azure Pipeline, Ansible is not a continuous integration tool. Bamboo is there, TeamCity is there, Travis is there. Okay, nowadays GitLab, Azure Repo, AWS Repo, multiple other tools also has come. Not Repo, sorry, pipeline, AWS pipeline, Azure pipeline. So multiple tools, kind of tools have come in the market, but still, guys, I do have experience in most of the tools. Okay, the best tool to work with is Jenkins. Yeah, circles here. A lot of tools are there, guys. I mean, in regional wise, geographically wise, a lot of tools are there, but still, world leader is Jenkins. Recently, I worked for a client in Azure, and I worked for a client in Bamboo in 2019. But I felt Jenkins is the best tool. Okay, because Jenkins has a lot of features are there, which makes Jenkins very powerful tool. Where is the Terraform used? Terraform will be used to spin up the infrastructure. Okay, to provision the infrastructure. Okay, for example, in cloud, if you want to provision your infrastructure, VNet or subnet or VLAN, etc., then Terraform will be used. Terraform will be used mainly to infrastructure provisioning for cloud providers like Azure, AWS, and GCP. Okay, yeah. So Jenkins is a world leader. What is the most important feature of the Jenkins? So guys, what makes Jenkins the most powerful application or tool is plugin? Okay, Jenkins is just a facilitator, guys. Jenkins will not do anything for you. Everything will be driven by plugin. Okay, everything will be driven by plugin. So guys, this is the thing is there, like in Jenkins, how the problem was earlier. Developers, they used to commit the code. Okay, it was difficult to integration, late testing, infrequent releases, and bugs people were getting in the higher environment at later point of time. Okay, this was a life before integration. I hope the code works fine in the testing. I have to check entire source code because source code is not working, because a lot of problems are there which people are facing when the code reaches to the higher environment. So software delivery process was slow because continuous integration was not there. Okay, and continuous feedback process was not there. Okay, now in continuous integration process, your frequent commits are there in the source code. The moment it will be committed, you will have your build, test cases, deploy, all the audit facilities will be available, all the audits will be invoked. Okay, which will in turn send you the notifications if any one of them would be failed. So for each and every commit or group of commits, you will be getting a frequent feedback. Okay, so before continuous integration, the entire source code was built and then tested. Developer have to wait for test results. After continuous integration, every commit source code is built and tested. Developer know the test result every minute, every moment for each commit. Okay, so let's see what is the continuous integration. So continuous integration is you compile the code, test the code, deploy the code for each and every commit. Now guys, let's talk about how we can use the Jenkins. So let me open a Jenkins URL. So guys, this is the Jenkins is there, which I just installed. Okay, this is one of the AWS machine I have. Okay, so guys, as I told, the most important feature of the Jenkins is plugin section. So this is the manage Jenkins part is there. Here we have multiple things are there. Multiple ways of configurations are there. So let me go to manage plugin section. Okay, so as I told in Jenkins, everything is governed by plugins. For each and everything we have plugin is there. Okay, in the available section, whatever plugins are being listed by Jenkins will be available in the inventory. This inventory, so like this 𝐓𝐫𝐞𝐝 runner, this is the code quality tool for .NET. Okay, MS Build, if you want to do MS Build, the MS Build plugin is there. For each and everything we have different plugins are there. You can see here for Azure, AWS, you have multiple plugins are there. So many plugins are there. You just give the name, you will see the plugins are here. Okay, in this installed sections, you will see the plugins which are being installed. I just installed Git plugin and the Maven plugin. Okay, you can see all the plugins will be installed. When I'm talking about a particular plugin, all the dependent plugins also should have been installed. This is an advanced section. You have HTTP proxy configuration is there. So guys, as of now, I'm working on raw network. I'm on internet. But in your company, you have to pass the proxy, which is enabling the internet for you. So that proxy details, you can pass it here. As of now, all the plugins which I'm showing you, that is already being installed. Okay, but let's say you will write your own plugin. Okay, you have to, sorry, not, it's a not HPF file, it's a HPI file. Okay, you can write your own plugin and you can import it over here. Okay, so this way you can install your own plugin. You can import it here, upload it, it will be listed in the section. So what I'll do is, let me install one plugin which would require for me build pipeline plugin. Yeah. So build pipeline plugin, I know it will be required. It will give me a view in the Jenkins. Let me install it without restart. You can see I just picked up the build pipeline plugin. It has picked up the required plugin as well. We call this concept as a transitive dependencies. Whatever transitive plugins are there, one is dependent on other, which will be installed automatically. Okay. Now let me go and restart the Jenkins. So guys, always remember after we install the plugin, you need to restart the Jenkins. I'll just restart the Jenkins. So our Jenkins is back. So guys, let me go and log in the Jenkins. So Edureka is my username password. So guys, you can see this plus sign is coming. If I'll click the plus sign, there is a build pipeline view is there. This view I wanted to bring. That's why I installed that particular plugin. Okay, this view I wanted to bring. So we'll go to the Jenkins. In manage Jenkins, guys, a lot of things are there. I'll tell you the important things. If you want to configure authentication and authorization, then this configure global security option will play an important role. As of now, I'm using Jenkins own database. My users are in Jenkins own. You can connect with LDAP, AD, okay, any third party authentication tool, and you can provide them kind of access. There is a plugin is there which is not installed. Matrix based plugin, there is a matrix based plugin is there, okay, which will allow you to have multiple users having different type of accesses. Okay, so for authentication and authorization, global configure security will help you. Okay, now for global tool configuration, if a tool is there which has to be configured globally, you can use this option. For example, I installed Maven plugin and I configured this plugin Maven over here. I given the name as a M1 and I wanted 3.3.9 release. Okay, because this is the most important release I've ever seen. Okay, like Git, JDK, other tools also you can install or configure. Apart from that, the most important section is configure system. If you want to configure something globally, for example, email you want to configure globally. Okay, so we have a section is there called email notification, which you can configure. If you have a particular Git plugin is there, you can configure it over here. Okay, so a lot of things are there. So usually we don't pass the IP addresses, we pass some DNS name to our Jenkins. That also can be configured. Okay, Jenkins will send an email. That email ID also can be configured over here. Okay, so a lot of things are there, guys, which you can configure in this section. So configure system is a section wherein you can configure the things globally. Okay, for example, emails you can configure, some particular tools you have configure. Okay, and Jenkins URLs you can configure. A lot of things are there which you can configure. In configure global security, you can configure authentication and authorization. In global tool configuration, you can configure the tools like Maven is a tool, Git is a tool. Manage plugin section, you can manage a lot of plugins, like I installed some of the plugin. There is an important section is there called Jenkins CLI. So guys, as of now I'm using Jenkins GUI. Suppose programmatically you have to install Jenkins and you have to operate Jenkins, so Jenkins CLI can be used. Okay, manage nodes is a section which will be used for a master slave configuration, which I will show you. Okay, and manage users means if you want to create new users, old users which will be residing in Jenkins own database, that can be configured over here. Rest of the features are, guys, not very important or not very generic. Okay, script console, if there is a groovy script is there, sometime some security features are being disabled. Okay, some security features has been disabled, so you can enable that security features using groovy script, so that you can run it over here. In my entire life, 10 years of DevOps career, I ran it only once. Okay, some defects are there which has to be fixed using Groovy. Okay, which are inbuilt defects of Jenkins, that also can be used. Okay, by running some script over here. Yeah, guys, so quickly what we will do is we will do one thing. We'll go and create a job which will do a unit testing, create a job which will do a code quality for me. We'll create a job which will do a code coverage for me, create a job which will do a compilation or build for me, create a job which will do a deployment for me. So for your information, guys, in Maven we have something called phases are there. Okay, and Maven plugin I already installed. So I will create a job which will do unit test cases for me, which will do a code quality for me, code coverage for me, builds or compilation for me, deployments for me. Okay, so all these things we will do it, and then we will connect this job using this plugin. Okay, so quickly guys, what I'll do is I'll go to the new item. I'll create a job called practice, and let me run a job which will do a compilation of my code. I will go to a Maven project. Since I installed the plugin of Maven, we will go with the concept of DevOps reusability. I will go to the source code management. In source code management, I'll select Git. This is a public repo, no credential is required. Now I'll go to the build step. pom.xml is already there, which is a Maven configuration file. I just need to pass my phase, like compile is a phase over here. Okay, apply, save it. Okay, and if I will do a build now, it will start building my code, as in like it will check out my code, it will start running the Maven phase. What happened? So build has been started. Yeah, I created a phase. I didn't create a phase. Phase are already being created. Compilation is one of the phase. I just called compilation phase. That's it. Now let's say guys, I have to create a new job, practice. Okay, I will write the job name test. Let it be a Maven project, or guys, for the reusability purpose, I can copy it also from another job. Practice, compile. So I'll go here. Only source code management will be same. Only I have to change is the phase. Instead of compile phase, I'll be calling the test phase. So what test phase will do? It will call the unit test cases. Let me build now. Okay. Now I'll go to the Jenkins. Again, I'll create a new job. Practice. This time, not the test job. I'll be creating a package job. Nothing, I'll be calling the package phase of Maven. Again, reusability, I will copy the job from another job. Package will do a build. It will create a package for me, guys. So I'll go to the build section. Instead of test, I'll be passing the package. Okay. Apply it, save it, and build now. So build is being scheduled. Now next is guys, I want to do a code quality. So practice code quality I will be doing. So what I'll be doing is I will write code quality. It's in my naming convention. I can give anything. And then I will go down, and here I will be copying the job from anywhere. Now only I have to change the phase. I'll go to the build, and guys, I know there is no phases there for PMD plugin. So I have to pass the plugin detail PMD colon plant. Okay, there is no phase, so I have to pass the plugin detail. So when you don't have phase defined in the Maven, like that, you pass the plugin detail PMD colon PMD. I'll apply it, save it, run it. Now I'll create one more job, which is code coverage. Code coverage. Let me copy it from another job. Cobertura colon cobertura. Okay, apply it, save it. Cobertura is a plugin, guys, which will be used for code coverage. Okay, so let these jobs be completed, guys. You can see we have created 5 jobs. Then we will connect them as a pipeline. Okay, so guys, our all the jobs have been completed. I think this Cobertura also getting completed. Yeah, everything is completed successfully. Now with my diagram, I have to connect them to call each and everything. Like unit test cases has to call code quality, then code coverage, then build and deployment. So what I'll do is first I will pick my compilation job. I'll go to the configuration of compilation job. Okay, I have a post build section is there. In post build section, I have build other projects are there. This is a section is there, guys, which will call another job. Let me call the test job, which will run the unit test cases. Apply, save it. Okay. Now you can see the downstream job of the compilation job is test job. Now let me go to the test job and then let me configure it to have post build action, build other project, and I will call here code quality job, apply, save it. Now you can see, guys, this job, which is the test job, it will be triggered by a compile job and it should be triggering a new job called code quality job. So one job is a upstream job, one job is a downstream job for it. Now let me go to the downstream job code quality. Okay, this will be triggered by the test job, but it doesn't have downstream job. So let me go to the configure phase, post build action, and our next project to be triggered is code coverage. So I'll call the code coverage, apply, save it. Now you can see the upstream job, this is a test job, and downstream job is a code coverage job. Now let me go to the code coverage job. Let me configure it to call our package job, post build section, build other project, and we'll be calling practice package job. Good, great. So guys, with my diagram, all the jobs are interlinked. This guy will be calling this guy, this guy will be calling this guy, this guy will be calling this guy. They have stitched that together, but guys, we have to show them in a graphical user interface also. So what I'll be doing is I'll be going to the Jenkins homepage. I will go into this plus section, and remember I installed a plugin build pipeline view. So I will say here practice pipeline. Now in this pipeline view, we have to give the detail of the first job. Okay, that is my first job. The first job is our compilation job, because in my diagram, my first job is compilation, then test, apply it, okay it. You can see a pipeline has been created. Now suppose someone will check in the code in the repository. So there is a ways there, hooks can be written which will invoke this pipeline. If the first job will be triggered, it will be triggering all the jobs continuously. For example, if I run this job manually, run, this will trigger the first job will trigger the second job, third job will trigger the fourth job, like that. Okay. And this pipeline can be scheduled also. This pipeline can be scheduled to run every second, every minute, once in a day, however you want. So there are multiple sections are there for scheduling the job. Like there is a poll SCM section is there, build periodically is there, webhooks are there. It all depends upon you. And you can see right inside top corner, there is an enable auto refresh button is there. Okay. With this, your screen will be getting refreshed, not a screen, I would say. Jenkins screen will be getting refreshed after every 5 seconds. Okay, you can see every 5 seconds it's getting refreshed. One by one, each and every job will be getting triggered. Right. So guys, now I will show you one more interesting concept. Now suppose guys, in my project I have jobs are keep adding. So one point of time, guys, I'm getting the performance issues. Let's say in my Jenkins I've got 100 jobs. Okay, so 100 jobs is definitely, it's not a good way. Okay, I mean, to improve the performance or to maintain the performance, because performance is going down. So what is the solution to that is, can we distribute the load among multiple machines? Yes, we can distribute the load among multiple machines. Okay, for example, I can create one machine like slave 1, I can create a machine like slave 2 and slave 3. So I can distribute the load also, and this mechanism is called distributing the load, or build distribution, or distributed builds, wherein what I'll be doing is, let the 25 jobs be running on Jenkins master. I'll be calling this guy as a master now. Okay, and on the slave 1 I'll be calling it as a 25 jobs guy. Slave 2 I'll be calling it as a 25 jobs guy. Okay, slave 3 will be calling it as a 25 jobs guy. Okay, so this concept we'll be calling it build distribution, or distributed builds. We'll be calling this guy as a distributed builds. We'll be calling it as a distributed builds concepts. In Jenkins, this concept is very important. When you'll go for the real-time world, distributed builds will matter a lot. So guys, distributed build is one of the way of running or distributing the jobs load. Okay. Other things are there, guys. For example, suppose this Jenkins master is running on the Linux machine. Like in our case, in my case, I pick up a Linux machine. Okay. Now suppose you have a machine is there called Windows machine. Okay. Now you have to automate some job, automate some task. Okay. Task. You have written the script over there. Let's say PowerShell script you have written. Okay. So now if I have to call this script automatically, it doesn't mean that I have to install Jenkins over this guy. What I can do is I can make this guy as a slave. I can make this guy as a slave. Jenkins slave. Let this guy be handling the load. Only this guy will facilitate or will govern or will administrator this guy, but this guy will be running the job. So what is the benefit making a guy slave? I need not to install Jenkins over there. There is a small utilities there which has to be installed on this guy, which will connect the slave guy to the master. Now suppose I have a machine is there wherein high configuration softwares are being running. For example, like SAP is there, or maybe what should I say, Microsoft machines are there, or maybe Oracle machines are there. If I have automated script is there, I have to call it. It doesn't mean that I have to install a Jenkins over here. I can make a guy over here who will talk to this guy. This guy will be slave for me. Okay. And then this guy will be administrating the load, administrating the hybrid operating system, administrating the different softwares automation also. So guys, to me, there are three reasons are there why you come with distributed builds. This is the reason one. This is the reason two. And this is the reason three. This is the reason three. Okay. So these three reasons are there why we go with distributed builds model. So guys, hope this is clear to everyone. Now guys, I will show you the scheduling mechanism quickly. So guys, if you go to the configure section, there is a build trigger section is there. Here we have two guys are there which are important. Build periodically. Suppose you want to run your job after a certain time interval. For example, every day, every hour, every minute. Okay. So we have a star mechanism is there. Like there is a star mechanism is there. If I'll pass 5 star, it means it has to be run every minute. Okay, so this is being inspired by the cron tab mechanism of Linux. Okay, when you read this documentation you will get to know, but whatever timings you want, you just type the cron pattern in the Google, it will give you the stars. That star you have to pass it here. So this is the build periodical method is there. But guys, suppose if there is a no change in your version control system, what is the point running the job? So for that, poll SCM is there. Poll SCM also, it will poll to your SCM version control system after a certain period, but it will invoke the job if there is a change in your version control system. Otherwise it will not. Okay, otherwise it will not. Okay, third option is your webhook, which is the third option is GitHub hook trigger for git SCM polling. Okay, the moment developer will check in the code, this pipeline will be triggered. Okay, so usually guys, when we talk about the scheduling, we'll talk about these three things. So guys, that's all from my side. Hope you guys enjoyed the session. Bye for now guys, and thanks for joining the session.